Good day from Australia. My name is Chari Pattiaratchi from the University of Western Australia, and I'm going to talk about extreme sea levels around the Australian continent. I'd like to acknowledge my co-authors, Yasha Hetzel and Ivica Jankovic. I'd like to also acknowledge that this study was funded by the Bushfire Natural Hazard CRC, and we also used the facilities of the Pawsey Supercomputing Centre quite extensively for our numerical simulations. The collaborators are Ivan Haig, Matt Elliott, and Sarah Pujera. So let's look at extreme sea levels that are due to many different processes at different timescales. So you have non-tidal systems such as El Nino and La Nina can change the mean water levels. Astronomical tides can change from diurnal to semi-diurnal all the way up to 18.6-year cycle. Then we have storm systems that create a direct storm surge, surface waves and wave setup, and meteorological tsunamis. We're not going to consider landslide and earthquake-derived tsunamis, but one important thing about these extreme events is that although these events can provide extremes, the timing is very important. So for example, if a very large storm surge happens at low tide, may not be as extreme as it happening and coinciding at high water. So this event here, you probably may have seen in the news. This is in Sydney. Here, the high water levels were created by wave setup and also high tides, with the peak of the storm coinciding with the high water levels. This is a little bit of a funny saying. We are recovering from a 15th once-in-a-lifetime disaster over a 10-year period. So again, let's look at extreme water levels again. This particular location is Broome in the north of Australia, which has a tidal range of 10 meters, but has, as you can see, quite low residual events, and each one of these red dots is due to a tropical cyclone. But an extreme event is that one, which occurred when this tropical cyclone directly impacted the location of Broome, creating a very large storm surge. When we look at the different tides, as I mentioned, we have tidal peaks that 12 hours and 24 hours, but you have many other tidal peaks as well. And we're more interested in these longer term ones, 4.5 years and 18.6 years, because they can modulate these extreme water levels. So the importance of that is that we try to get and look at a 60-year record so we can at least capture some of the events of these long tidal events. But unfortunately, there isn't a records that extend for 60 years of measurements. There are few, but many are only about 30 to 40 years long. So therefore, we want to looking at, if you look at whole of Australia, we need to go into a numerical model, and extremes can be derived by running a long-term simulations. In our case, we did a 59-year simulations to extract these extreme statistics around Australia, and this website is a picture. This image is from this website that you can access. So we have data or model output at 2-kilometer resolution around the whole of Australia, and that provides around 31,500 data points around the whole of Australia. So the model that we used was Unstructured, SCHISM. We created a bathymetry using a variety of different sources. We have 100-meter resolution at the coast along the whole of Australia, and in the deeper water we had 10-kilometer resolution, and this was done through the possibility, or was made possible by the Pawsey supercomputing facilities. So very high resolution in all of the coastal regions. So the forcing, we use the GRA 55 database to create our meteorological forcing. We have the global tidal model, and then tropical cyclones. All of that goes into the model to give us the total sea level to provide a 59-year time series. So here we are looking at predictions in red and observed in blue. The correlation is about over 0.9. And this is telling us an annual record for 1981, 1996, and 2007, just randomly selected for the stations from north of Australia. This is in Queensland, all the way clockwise to Western Australia. So here you also see very different. So we have events which are dominated by the Southern Hemisphere winter months in the Southern Ocean. Then we have in the north these events which are due to tropical cyclones. So again, going around Australia, we see Port Hedland, which is here. Tropical cyclones come up, Fremantle, extratropical cyclones, the Southern Hemisphere storms in the southern parts of Australia. Then when we go back to Queensland, we see the events due to tropical cyclones coming up as well. So when we look at, in this particular case, we're looking at monthly maximum sea level. The red line tells us the 1 in 100-year event. So this is for Broome. You can, the strong tidal influence, and we have a tropical cyclone. So here, the semi-diurnal system has a 4.4-year tidal cycle, and that gives us the modulation in the extreme events at that period. When we come to Carnarvon, we have tropical cyclones, but not as often. So you may have one or a few of them, and then again, one event in 1964, in Carnarvon. But when we come to, I should also say that in here, the y-axis is very different. So this is up to 3 meters. This is only up to 1 meter. In Fremantle, we see the again, 2 main parts. We have an 18.6-year tidal cycle, and then we also have the El Nino, La Nina events. During the El Nino events, the water levels, the mean water level is high, and then you have higher extreme levels. When we go to Sydney, we have East Coast lows that are important in that system. So this is the event that I showed you with the swimming pool in the water. Then we go to Southern Australia. The winter storm surges are important, as well as the fortnightly tidal system. So when we look at our website that I'll demonstrate at the end, we can go around Australia and look at the annual recurrence intervals. So to demonstrate, we can actually, this is north of Australia. We can keep zooming in to different points. So this is the scale of the annual recurrence interval, so of 1 in 100. So in these regions, greater than 5 meters. And then you can actually click on any of these points spaced at 2 kilometers. You can get the extreme value statistics. So this is for Southern Australia. You can see the recurrence interval up to 1,000 ARI, but we highlight the 1 in 100. And then we can also look at the occurrence of the sea level at seasonally. So in Southern Australia, the winter storms, the Southern Hemisphere winter, you have much more extreme water level occurrences in winter compared to the summer. But on the other hand, if you go to north of Australia, then the summer months, you have higher incidence of extreme events due to the effects of the tropical cyclones. You can also download the data as a netcdf file for any of the points to give you a 60-year tidal sea level record. We can also examine the sea level around Australia. So here, north of Australia, now we're going anti-clockwise along the coast. So this area here is very much affected by tropical cyclones. So the sea level, the annual recurrence intervals up to more than 5 meters. And then as we come along to the south, you actually have the effect of the tropical cyclones are less. You come down the south coast, not much extreme events in terms of the magnitude. And then they increase as we come to South Australia, where the winter storms from the Southern Ocean has a big influence. Then we go along Victoria, New South Wales, all the way up to Queensland. And then the tropical cyclones have a peak and then a reduced effect. And then when we go to Northern Australia in Gulf of Carpentaria, these values increase as well. So in terms of summary, we have 59-year model hindcast of sea levels. These extremes are due to a whole number of different processes, and then this data is available on this website. So here is a simulation of the sea levels over the in January 2011. You have many cyclones in here. You can see here, and then another one. It's very hard to keep up with these. And then you have the large storm surges, and on the south coast we have the systems which are going through. So now this is playing it again. So you see the tropical cyclones on both sides of the coast, and then we have this passage of storm systems along the south coast. I'm now going to give you a quick demonstration of our website. So we can pick any location. So I'm going to look at, so the blue actually is the sea level. We can pick a tick. You can actually look at the annual recurrence interval. So here you see at this location, the 1 in 100 year is roughly 4 meters. You can look at the seasonal variability that I showed you, and then you can also download the netcdf file or download all the plots as a PDF. With that, I thank you. Come and visit the website, and you can learn a lot from looking at sea level records. Thank you.